join computer audio. Let's share screen. Let's refresh so that you can see it on the big screen. All right, so plan for today is to pick up from lesson 7, bubble 8, which is where we are in 3rd period, but other classes, you can skip ahead to where we start lesson 8 since we finished lesson 7 in the other classes, but this video is going to go from the last 3 bubbles in lesson 7 all the way through lesson 8 and pause it as you need it. Okay, so for bubble 8 from lesson 7, we are going to use the red, green, blue alpha, which is another way of using colors. So far, we have done red, green, blue, where the first one is the amount of red, the second one is the amount of green, third one's the amount of blue, which you can use now that we have a pen RGB block that includes a 4th parameter. You can use later on, you can use any one of these, either pen color or pen RGB. And even one of the 4 options for this is the RGB alpha. The program knows that if you send it 4 parameters, the first 3 are the amount of red, amount of green, amount of blue, and the last one is the alpha. For this particular bubble, you do actually have to use the pen RGB, so that's what it's actually checking for. In App Lab and a lot of places, if you send the program or the function 4 parameters, that last one is the alpha, and the alpha is the opacity, meaning how opaque it is, and it's on a scale of 0 to 1. The red, green, and blue are each on a scale of 0 to 255 still. I don't think we've talked about hexadecimal. We may, but the key is the RGB of 3 color, the triplet of RGB or the quadruplet of RGBA. But for this one, we are trying to recreate these 2 colors or these 2 dots. And so let's start with figuring out a dot. How big is this dot? Let's see what 50 gets us. And we'll speed it up. Okay, that's about the right size. Let's pick a good color. This is kind of a pink color. So let's go full red. And well, let's just see what full red looks like that. But we clearly want it to be translucent. So let's go with 50% opacity, which is 0.5. And it looks like this. This is a little bit towards purple. So let's up the blue. And this ability to sort of figure out a color from or figure out a color's RGB values just by looking at it is nice. It's not super critical. Let's up the green and see if we can move it towards the middle a little bit. No, let's bring that back down. Let's go up here. Let's just get something close. That's fine. The key is that you are using the pen RGB block with a partial opacity. So the last value needs to be between 0 and 1. And then we need to move forward far enough to draw the second block, which if it's going to, the center point of the second block is outside of the first, or second point of the center point of the second circle is outside of the first one. That means the distance we move forward needs to at least be the radius of that. So let's see what 50 gets us. And another dot of 50. We obviously are going to have to change the color, but we go like this. You can see that it draws the line of the move forward. And even if let's change the color, pen RGB, before we draw the next dot. Let's just make it pure blue, but 50% opacity just for the sake of checking on things. Okay, you could see it drew a line that it moved forward before, and we don't want that. So we need to do pen up before we move forward so it doesn't draw. And you're going to see a lot of pen up, move forward, pen down. For those of you who are already on bubble 10 where it says draw your own, we're not drawing your own. You're drawing the iHeartCS thing there, because. Okay, let's see if we can figure out, this color's a little closer to purple, so let's add some red here. Something like that. The key is for this, I need 2 different colors with partial opacity, meaning the alpha needs to be between 0 and 1. 0.5 is fine, and let's see if it lets me. There we go. Okay, bubble 9. Is this the smiley face, or is that the last one? Yeah, smiley face. All right, so that's the way that looks. Let's go ahead and work through this. Okay, so let's just do, well, we know the background and the head. Let's start with a dot. Let's make it, the background color is, let's just call it powder blue. And make a dot. We know a dot of 400 is big enough to make the full background. Then let's make a yellow dot. We need to change the color before we make the next dot. And we know that the entire width of the screen is 320. So that means if we make a circle with a radius of 160, it's going to touch the edge exactly, which is not what we want, because we want it to, we're trying to recreate this as accurately as possible. So we want a little bit less. Let's try 150. We know how people think when they design things. It's probably a multiple 10, if not a multiple of 50. And there we go. All right, so we have, let's start with the eyes. The key is we need to find this XY location. A couple ways to do that. One, just sort of by guessing and using some logic and trying to walk it in. The other way is to, if you stop the app from running, meaning click on reset so that it still says run, and you mouse over the screen, you will get XY coordinates, which this will at least give you a starting point to guess where something is. And I think this is somewhere around, let's say 120x, meaning the X value is 120, which means it's 120 pixels from the left edge. Remember, X counts up this way, Y counts up that way. So let's call this 120 from the left. And our Y value is probably going to be, let's try 180 and see what happens. All right. If you've noticed a pattern, some of the time I do things wrong first for the sake of demonstrating how to solve problems. Thank you, though. Appreciate it. Okay, so let us change the color to black because we want a black dot. And we're going to use move to, instead of moving a direction, we can move to a specific location now, which, what do we say, 160 by 180. And let's make a dot there of, I don't know, 10 and see what's going on. Okay, so I did not click it correctly. First of all, you can see that we drew a line, and you are going to do, I intentionally did that, I forgot the X value. You are going to do pen up anytime you use move to, because you don't want it to draw as you move, unless you want it to draw as you move. And so for this one, it doesn't matter because our next move is a dot, and you don't need pen down in this case to do a dot, but you might as well get in the practice of doing pen up, move to, and pen down whenever you move something. So let's see, what did we say 120 by 180, and clearly that dot is too small. Definitely a bigger dot. Let's see what 30 gets us. Maybe too big. How about 25? And then location. Location's not bad. It's good enough for now. Okay, so how to find the other eye? Well, we know, actually that's not that good, but let's try 110 just to make it a nice even number. Although, yes, I know 120 is even, but you'll see in a second. Okay, so we need to find the XY location of the other eye. We know it's going to be the same Y location. They are the same distance from the top. So we will keep 180 as its Y location. Question is, this eye over here, how far is it from the left? Well, we know this one is 110 from the left. And we know that there is an imaginary center line that is 160 from the left, because we're working with 320 overall. So if this is 160 from the left and this is 110 from the left, that means it's 50 from the center, and the other eye needs to be 50 from the center. So that's going to put us at 50 plus 160. So our Y is going to be 210. So let's do a pen up, even though it's not necessary at this point. Let me get some white space here. Pen up, move to pen down, and we have the same Y location, which is 180, and the same, and the X location is 50 to the right of center, which is 210. And we need another dot of the same size, which was 25. Let's see what that gets us. Yeah, all right, that's good enough for now. Okay, so for the smile, the face, the mouth, we're going to use an arc. And the way arcs work in App Lab, we talked about this, I think, with the squiggles, is they start from its XY location is the start of the arc. There are other applications and libraries and programming languages where the XY location of this arc is its center point, and then you would dimension or put in the dimensions of the arc based on this XY. But for our sake, we need to find this XY. We then need to point the cursor straight down and do an arc left and some other things. But let's go ahead and figure out this point. You could do it here and arc right, it's the same thing. But let's see, we want to find this point. We know this point is 110 from the left. Let's say this is halfway would be 55. Let's say it's 60 from the left. So we'll do a pen up. I'm going to put some white space in here. So this is the second. These are the eyes. That's the background. Let's do a, oh wait, pen up goes here. We'll do a pen up, move to pen down. And the move to, we said, was about 60 from the left. And if this is 180, halfway down is, let's see what 240 gets us. And where does that put us? A little high. I don't know. Looks fine, I guess. We can maybe 250. Okay. And then in order to draw this, we need to turn 2. So far, we've mostly used turn right a certain amount, turn left a certain amount. But turn 2 will pick a specific angle regardless of where the cursor was originally. So it doesn't matter what you just finished drawing, you can pick. And we want it to be pointing due south, so that's 180. Okay, and we need an arc to the left based on where we are. Let's see what the default gets us. Clearly, that's not it. We definitely want a 180 degree, which will give a full smile, but we need to figure out how big this arc is. Okay, we know it's centered left to right, and its radius is the distance to every part of this, even including where we're starting. So its radius is how far are we right now, or in a second, away from the center. This XY is 60, or excuse me, this X location is 60, and our center is 160, so our radius is 100. So we'll make an arc to the left with a radius of 100. There we go. And we obviously need a larger pen width. anytime before we start drawing. Let's see what 20 gets us. There we go. I think it might be a little bit low. It looks a little dipped down, but maybe it's 240 back to where it was, but that's pretty good. All right, so the last one for lesson 7 is the iHeart CS example, which will look like that when you're done. Let me restart here. Okay, we always start with the background. So let's pick a pen color. I think light green works good for this. And we need a dot that fills the background, which is 400. Double check, good. All right, so I could do both of the purple things first and then the red thing, so I don't like to change, but I'm just gonna work top to bottom. This letter I is centered. We need to figure out, we can either jump, do a move to this point and turn due south and go forward that amount, or we could jump to this point and just continue up that amount. I'm gonna jump to this point, turn due south and move forward. So this point we know is centered left to right. Question is how far down? Let's start with 20 and see what that looks like. So you don't have to put white space in your code, but I recommend just creating a bunch of lines and then a comment at the bottom will give you some white blocks to work with. And you don't have to comment as you go, but it's not a bad idea. Okay, so the background looks like that. Let's do another comment for letter I. Okay, so once again, anytime we move to, we're going to do pen up, move to, pen down, pen down. And this location that we said, let's go like that, get a few more pixels, is going to be centered left to right. So that's X 160 and the Y, I don't know, 20 down. And we need to draw this, we need to change the color to purple. In the order of pen color, pen width, and turn don't matter as long as it's all correct before you do a move forward. Let's do a turn to 180 is due south. See where that puts us. Good. It's probably a little bit lower than that, maybe 30 on the Y. There we go. And let's do a move forward. Let's start with 100 and see what that looks like. We're probably going to need a pen width. That's right, I forgot. Pen width anytime before you do move forward. Let's see what 8 looks like. Yeah, all right, it's a little long, I think, maybe 80 long. It's going to get into the heart. All right, so that's good for the letter I. Let's draw the heart. And the way to do the heart is actually in 2 steps. I'm going to do the right side first. And there's a couple ways you can do it, but I think the easiest way is to jump, do a move to this point northeast, which is 45 degrees, and do an arc left, and then jump back to this point northwest, which is either 315 degrees or negative 45. It will take that too, and do an arc right. So either way, we're going to grab pen up, move to, pen down. And the location we want, this bottom center of the heart, is centered XY, excuse me, centered on the X and it's Y. Let's just see what 240 looks like. Okay, and how's that look? Boop. Maybe a little lower, but we'll figure this out first. Let's turn northeast, which is turn 245. Switch it to red, pen color red, and where's my speedometer? There we go. And the size here, I'll just go ahead and tell you, I'm pretty sure it's 50 this way. And because if you connect all of these points, it pretty much makes a square or a diamond. That means the diameter of each of these arcs is 50 also, but the dimension we want is the radius. So the move forward is going to be 50 and the arc radius is going to be 25 to the left. So let's do a move forward of 50. There we go. And an arc left. It is a full semicircle, which means it's 180 degrees of arc and 25. There we go. And now let's do the left side. And it's going to be essentially the same as this. So we can just copy this with a couple of changes. Let's see where we have right here. It's definitely not. Well, if you do that, it doesn't, just draws it twice. We want to turn to negative 45, which is to the northwest. And when we get to the end, we want to arc right. So we'll change that left to a right at the end with the same dimension, still 180 degrees of angle and 25 pixel arc diameter. Okay, and after that, we can just do, let's do letter C. Okay, let's do some planning. We know that the start of the letter C is going to be left of center, so the X is definitely going to be less than 160. Let's say its height is 100. So that means when we draw this arc, it's going to be radius 50. And we can plan out on the letter S that it takes 2 arcs to do that. That means each of these arcs is going to be 25. But we'll just work with that when we get to it. So we need to jump to this point. So let's do a pen up, move to, pen down. And the move to needs to be less than 160 on the X. So closer to the left is 140 and lower than 240. Let's see what 310 looks like. I like that number. Probably a little bit. Well, let's see what happens when we start drawing. Okay, in order to draw, we need to change the pen color back to purple. And we need to turn due west. Due west is either 270 or negative 90. And we need an arc left. Because as we're facing this way, it's a left-handed turn. We know it's a full semicircle. And we said we want the total thing to be 100. So that means the radius is 50. All right, that's pretty good. And let's do the letter S. And it's going to be still a pen up, a move to, and a pen down. And let's choose, well, let's just start here. Okay, we know, actually, let's jump to this point because we can say this point is the same distance away from center as that point. So, and it's at the same Y value. So if we chose 140 from here, that's 20 from the center. This is 20 off the center line. That means this point right here is 20 going the other way. So we need 180. Move to 180. Letter S is 180. And we started our letter C here, which was 310 from the top. And we're 100 lower. So let's make it 410. See where that gets us. That puts us right there. Fantastic. So we have a couple of arcs that we know are 180 degrees of arc, just like we did the squiggle on bubble 7. And we know the radius is going to be 25, so that 2 of them are the same height as the letter C. But there's a little bit of straight there. And let's go ahead and put a move forward. Let's see what 25 looks like. Then we have an arc left as we go. We know it's 180, 25. Then an arc right, 180, 25. And it's probably the same amount on the other end. We're going to have to refine it here in a second. So that's another move forward, 25 at the end. And so it looks like this. And that looks like too much on the straight part. So let's decrease this to 15 and to 15. And that doesn't look too bad. I actually think the first move forward, the one on the bottom, is longer than the other one. So let's see what that looks like. You don't have to refine it this much. The key is you're learning how to do pen up, move to, and pen down. That looks pretty good. There's another block called hide. And what that does is it hides the actual turtle. And when we get into more complex things and fancier things, and even now, you can just throw hide right at the beginning of anything, because you don't actually need to see the turtle do anything. It's doing it. And there you go. That is bubble 10. We'll go over the checks for understanding at some point, but I want to jump right into lesson 8. Okay, there's a short video, so please pay attention. We are going to do parameters just like we did for the last time, but instead of having functions that are already defined for us and working in the background, where like the length of move forward and the angle of turn, we are going to define and create our own functions that are designed to receive parameters that we choose. And the video here, let's go ahead and watch it together. It's brief like all of them. Let's turn on the volume.
You've already seen that some functions are defined with parameters to make them more
Somebody's head is in the way.
useful.
Give me a second. Let's try this.
For example, the original version.
Nope. Let's try. Give me a second here. This not on. Sorry.
Of move forward, move the turtle exactly 20.
All right, guys, you need to be quiet, please.
You've already seen that some functions are defined with parameters to make them more generally useful. For example, the original version of move forward, move the turtle exactly 25 pixels. This doesn't give you a lot of options on how to design your drawings. A much more useful version of move forward is one that accepts a parameter that allows you to specify exactly how far forward the turtle should move. Up to this point, the functions we've written ourselves don't have any parameters, but the ability to write your own functions with parameters is both useful and powerful. So let's see how to do it. Here's an example. Look at this function that draws a square with sides that are 100 pixels long. If we wanted to make a function to draw a square with sides 50 pixels long, we'd have to make a new function that's almost identical to the first one, with the only difference being how far the turtle is moving each time. If we wanted even more options for the size of the square, every time we would need to declare a new function. Yeah, that's not very good, but luckily there's a better way. The solution to the problem is the ability to create a function that accepts a parameter. A parameter is a named value that is provided as an input to the function. We saw that our version of draw squared has a lot of code that was repeated. The turtle was executing the same basic behavior, just moving by different amounts. It turns out that we can express this generalized behavior in our code as well. Here's a new version of draw square. Here, we've made the size of the square a parameter of the function. Notice that the function heading declares that it needs an input. We've given a name to that input, and that name is size. Everywhere in the code where we need to use that value, we just enter the word size instead of a number. Writing a function with a parameter is very similar to writing a function without one. Just drag the function block that shows a parameter and drop it into the workspace. We add the name of our parameter inside the parentheses in the function call, like this. Just as giving a meaningful and descriptive name to your function is important, so is deciding what to name a parameter. The name of a parameter should give some insight into what the value will be used for. In this case, we've chosen the name size to indicate that you can set the size of the square when calling the function. As a programmer, what you call your parameter is your decision to make. We can write the body of a function like this. The parameter, size, acts like a placeholder for that value. Wherever we want to use that value, we just refer to it as size instead of a number. Let's look at what happens when the function is called. Now, when a user calls draw a square, they call it with a value like this. We say the value of 63 gets passed to the parameter of the function. The parameter acts like a container with a name on it. Whatever value is passed into the function is stored in that container. Inside the body of the function, you will want to use the value stored in the parameter. To do so, you must refer to the value by its name. As the program is running, whenever the word size, in this case, is encountered, it's replaced by the value stored in that parameter. Adding a parameter to our draw square allows us to generalize its functionality. In other words, our function is useful in an entire range of situations, as opposed to just being useful in one particular instance. The result is a function that gives you much more flexibility and control without the need to create duplicated code. Once you've added a single parameter to your function, you might realize that there are multiple aspects of its functionality you'd like to generalize. For our square example, you might want to change the width or, say, the color of the line. To do this, you can simply add more parameters and separate them by commas. You can then use any of these parameter names in the body of your function. When calling your function, you'll need to include multiple values, one for each of the parameters and each one separated by commas. Parameters are another example of how abstraction can be used to solve problems. When confronted with a group of related problems, we first work to identify patterns across all of them. In doing so, you might realize that using parameters will let you define a single function with general behavior that can solve any instance of the problem with one piece of code. This is a powerful skill that removes the need for creating duplicated code and leads to programs that are easier to read, write, and maintain.
Okay, so this is our more advanced function uses, or creating functions that are more useful. And there are a couple of key aspects to this. The key is that the definition, the big block, will, hold on, is this, what does this do? Okay, here they are giving you a function definition called draw square that receives a parameter called size. Now, it's called size, it can be called anything, but the key is that the word that you use inside of the definition is that. Okay, there are some reserved words that you can't use, just like in naming functions, but if you accidentally choose one, it will let you know. In our actual function calls, we have a move to, or pen up, a move to, then we call the function draw square and send it a value of 100. It knows there's only one parameter. We call draw square. It checks. It's only expecting one parameter. It gets 100 there. And then anywhere in the function you use the word size, it will give it 100. So when you call this, we do pen down, move forward 100 got passed to it. Turn right, move forward 100. Turn right, move forward 33. That doesn't make any sense because none of the distances, this would be called hard coded rather than giving it a parameter. We don't want that. We want to be able to use it for any size. So we're going to make sure that says the word size. And now we can then do a move to a specific location and call draw square, giving it the distance or the size of 25. And it does the same thing, except everywhere, every move forward gets the 25. We could include the move to in the parameters. I'm not sure if they do it also, but you could call X location, Y location. You don't have to do this, but you could learn. And then at the beginning of the function, we'd do a pen up, a move to X location, Y location, and in the function call, actually put in extra parameters, and that would save you a move to every single time. What was the other one? Like 3, 2, 7. Doesn't matter. But the point is you can have extra parameters, and I'm pretty sure they talk about that later, and we wouldn't need this. Okay, so you can fit multiple things, and it knows that the second and third comma separated value in the function call gets applied to this word, and anywhere in the function that uses that word will get whatever number is there. All you really need to do is change that 33 to the word size, and we get to move on. Okay, lesson 8. We need to make a function that draws triangles. They have already given us the pen up and move to that they want, the location of these triangles. We need to write a function that will receive a parameter, whatever value gets sent to it. In this case, they want these two, and they already give you the location. So, and we have a pen up. So at this point, anytime the function is called, it already has a move to, so we can just start with a pen down. And we're assuming it's pointing straight up, so we're going to move forward. How much are we going to move forward? We're going to move forward side length. And we only want this to be triangles, which means it's always going to be 120-degree right turn. Oh, actually, these go to the left, excuse me. I suppose it doesn't really matter. And it's move forward side length, turn left 120, move forward side length, turn left 120, move forward side length, turn left 120. Let's see what that does. I think that might do it. Nope. And we need to end the function with a pen up. So almost all your functions are going to have the pen up needs to happen. Well, you can figure it out as you go which one needs to be pen up and pen down if you don't want it to draw lines as it moves to. All right, bubble 5. We now need to write a function that receives 2 parameters. So we will be able to draw a square of any size and any border width when we call it. So it starts with draw square of, we have size, which is going to be its move forward, and its border width is already being sent to pen width. The word border width is our choice, but it makes sense. It's meaningful and descriptive. We just need to call this function. This function looks fine as it is. So we're going to call a function that receives a parameter, which is this one. You can go into text mode and add a parameter. I don't think it will. Yeah, it will. But that's all it is. It's just something in the parentheses. And you can add parameters like that, add spaces. But the first one we want, does it say? Okay, the first one is a size, let's say that's 80 on each side and a pen width of 6. Oh, and we got to put the name of the function in there. So we're still, this is the function call. This is the function definition. They need to have the same name, case sensitive, everything. The call tells the definition, what the various values should be, and they need to be in the right order. And then let's see what this does. Good. And then the other one, let's do another function call of, it's a little bit smaller. Let's say it's 40 on a side, but bigger border width, say 10. And I don't think this is going to be right. Oh yeah, got to name it the right thing. There you go. A function that receives two parameters, two specialty variable values, versatility characteristics. I don't know. All right, so we now have some function calls. We need to define, we need to put in a function definition. I'm going to add some white space here with just some lines and a comment at the bottom. So I have some blocks to work with. So I need a function that, the function definition that corresponds to draw triangle. So I'm going to put the same name in there, and it receives two parameters. The first one is side length or side size. It doesn't matter so long as that's what you use in the function. And the other one is, what is it supposed to be? Pen width, pen size. You don't want to use words that are already used other places. All right, so we are going to, let's see, I think we probably should start with pen down since the other one is going to do a move to and finish with a pen up. And our triangle is what? It's move forward. How far do we want to move forward? We want to move forward side size. You can do side length or whatever. And we want our rectangle or our triangles, they're left turns in our case, left turn 120. And we want three of these. We want to move forward side to size 3 times, or move forward, turn left 3 times. Let's see what this does. Okay. We did not send it. We did not use pen size. So we need to set pen width to pen size sometime before we draw the first triangle. And there you go. They've already given us the function calls with the parameters they want to use. And you notice that even though I have a parameter here called pen size, it's never used in a function. That's fine. It's kind of pointless, but it doesn't break it. It still knows the first number that comes through in parentheses gets applied to this word, which anywhere in the function will use it. And let's move on. I don't know why, it's just another explanation. Which of the following, here's the answer, which of the following is not part of the defining a function, giving the function name, you need to do that. Identify, well, here's the answer. Identify the parameters, give the parameters a value, adding code to the body. Not part of defining a function. We are not giving the parameters value when you're defining. You give the parameters value when you call it. So it's this one. Sorry. All right, so comments, I've been showing you some comments. It's // on any line, and it deactivates that line or lets you write in the code that the computer won't think it's actually code. And it's good for notes to yourself or notes to somebody else or notes to yourself in the future to help explain what's going on, or just keeping track of a to-do list, like what you need to do coming up, you know, keeping notes, that sort of thing, spacing things out. So there you go. Comments are good. And let's see what we have here. All right, so the next few are chained together, and we should be able to get through all of these, I think. But we have, let's see what we have. We have a hide and pen up. That's always a good way to start your program because you're probably going to start with a move to, and there's no reason to ever see the actual turtle. And well, never a bad idea to just hit go when you get to a bubble just to see what they're giving you, whether or not it works. We have, let's look at the function calls. And then if we need to look at the function definitions, it is generally going to be set up this way where the definitions are below or lower on the code than the calls. And that way you can keep the calls up at the top where it makes sense and where you can mess around with them. And the definitions are just what's going on under the hood later on. And we have a function call for draw background, which is just dark blue and a dot that's gigantic. Then a move to and draw starfish, which does all of this. No, does all of this, a bunch of turns. And then the rest of them, what are we actually supposed to do here? Add a comment. We need do this. Insert a comment that says draw all starfish just above draw starfish. Above draw all the seagrass. It shouldn't be draw all. Well, we'll deal with it later. So there is a function block, or excuse me, there's a comment block in the functions tab. So I suppose we're supposed to put it there and have it say draw all the starfish, even though this is really just draw a single starfish. Not a huge deal. And is that gonna, are you finished? I think that's right. Next bubble, bubble 10. We still the same thing. Okay. So under the C, the next several challenges working on one program where each bubble is going to add to it slightly. And then we're going to read through, add function calls and definitions as needed. We are going to draw multiple fish, multiple starfish, and multiple seagrass. We will need to do move to before drawing a second fish and test out the code. So for this one, we are just adding to the draw. Well, we're adding to each of these. So we're going to call draw, let's just work through starfish. You can copy and paste. And let's see, does draw starfish end with a pen up? It does. But in order to draw it in a different place, we need to give it a new move to. And let's put it over here. Did they give us dimensions? I don't think so. If we want to put it over here somewhere, actually, it's over here somewhere. We need a lower X and a higher Y. So let's see what 70 and 425 gives us. Okay, there's two starfish. And yeah, we're supposed to do two of everything at this point. So draw seagrass. We need another one of those, but a move to above it. Let's see if draw seagrass ends with a pen up. It does. That's good. So our second draw seagrass. Move to 50, 40, what? Move to, oh, I already brought in the move to. So the seagrass, if you watch it being drawn, gets drawn from the bottom up. So the seagrass X is going to be where we want it left to right, but the Y is always going to be maximum. Okay, so our XY for our new piece of seagrass, the Y is going to be all the way down at the bottom, and the X is a little bit to the left of what we have. We already have 50. Let's see, 25 in our second seagrass. Oh, and we need a turn 2, as is there. Turn 2 sometime after we do the move. And okay, a little too close. So I guess the second seagrass needs to be to the right of the first one. Let's see what 100 gets us. There we go. And we need a second fish, which is right here. So we need another move to and another draw fish. And our second fish, I believe the fish starts as this as the XY. So we need a higher X value to push it to the right and a higher Y value to push it down. So it's probably like 180 because it's a little bit right of center. And let's see what 200 does for a second fish. And there we go. 2 fish, 2 seagrass, 2 starfish. Okay, and we want to be able to change the size of each of the fish, each of the starfish. So we are going to add a parameter to starfish. Let's add it to the definition first so that we have somewhere to send it. So let's find the definition of draw starfish. And let's allow it, let's give it a size. I think size will work. Sometimes size is reserved. And we're going to put size everywhere it's a move forward. So move forward, instead of moving forward 60, we're going to move forward size. Instead of move forward 60, we're going to move forward size, move forward size, move forward size, move forward size. But and then in order for this to work, we need to go back to the function call and put in sizes to give it. How about 60, which is, we know, a good size for the first one. And the second one, a little smaller. Let's see what 40 looks like. There we go. A big one and a small one. Because we created a parameter in the definition. We created a parameter to receive. We used that parameter in the function definition. And then when we called the function, we sent it a value to be used. In this case, that only value is used as its side length. So we're good. And move on. Okay, seagrass. Seagrass needs a parameter. And the only one we need is to change the size of the arc, because the height of the seagrass is just arc left, arc right, arc left, arc right. But the size of the arc, 4 times is how tall it's going to be. So we need to add a parameter to draw seagrass. Let's go down to the definition of draw seagrass. There you go, draw seagrass, and let's just call it size. It is technically not awesome to reuse it in different places, but it gets overwritten every time it's called, so it's actually fine. And size is the amount of arc radius. In this case, it's radius, so we're going to put the word size everywhere in the arc in the second parameter of the function call, which now we're getting a little layered, but we are sending, when we call it, when we call the function seagrass, we'll put a number in parentheses. When it gets sent or passed to this definition, it will, everywhere inside of this function that uses this word, will get that number. And in this case, we're using it for the radius value of each of the arc calls. Now we need to go back to the function call, which is draw seagrass, and give it some value. Let's just make one a 100, and the other one was smaller, I think. It doesn't have to match as long as it's two different sizes to prove that you're using a parameter. Let's try 70. Okay. I don't know. It's always fun to try and make a match. Let's call this one 30, and this one, what was it, 100? Oh, I changed the starfish size. My mistake. Yeah, attention to detail. Let's call this one 50, and this one 100. There you go. That's pretty good. Those are probably the dimensions we're working with. And so that's it for seagrass. And so now we need a parameter for draw fish so we can make fish of different sizes. So let's go down to the draw fish definition. Draw fish and allow it to receive a parameter, which why not call it size? And so we have a dot. The original call uses a dot as, actually, let's just watch how the fish is drawn. The fish is drawn with a dot and then some lines. So in order to make it the head and tail larger, we need to change the size of the dot and the sizes of the move forwards, not the turns. The turn are angles, but we want to give the fish a parameter called size. And anywhere we do a thing that's a size, like dot is a size, move forward is a size, move forward is a size, move forward is a size, and move forward is a size, we want to be able to give that function a custom value every time. And so let's call this one 30, and let's say this one is 60. See what we get with that. And we'll speed it up. And okay, so 60 is a little big for that. Let's see what 40 and 20. We could affect things like the pen width so that the center of the fishtail doesn't make a gap. Did I change something? Maybe I definitely changed something. Dot, move forward. I think pen width probably needs to scale. Let's see if pen width needs to be the word size. Yeah, it looks a little better. Okay, so that it fills in and we are good. Draw fish, change the size, and that looks pretty good. Yours doesn't have to match the example exactly, but why not? Couple more, almost done. Okay, so we want the ability to draw fish of different colors. So that means we are going to send it a different color every time we call it. Okay, right now our draw fish only receives the parameter size, but we want to be able to send it a color also. But the way we're going to do it is by sending it a value for red, a value for green, and a value for blue. So we need 3 more parameters. And you could call these parameters red, green, and blue, but just to clarify that parameters don't have to have the exact name, I'm going to call it redness, redness, greenness, 2S, that's not having a word, greenness. Let's go, and blueness. And so that means inside of the function, when I call the function, I'm going to send it 3 parameters, a value for the red, a value for the green, and a value for the blue. So we need 3 more parameters when we call it. And this parameter, the second number in the function call is going to be applied to the red. So if we want the first one to be red, it's going to be 255 for the redness, 0 for the greenness, 0 for the blueness. And for the other fish, let's just make it blue, which is 0 for the red, 0 for the green, 255 for the blue. And then down in the definition where we are receiving these, we want to apply whatever number comes through as the second parameter to the red of pen RGB, the second number that comes through to that, and the third number that comes through to that. Let's see what that does. There we go. Okay, is it making you do random at this point? No. Well, it gave different values, but that's not super important. The key is we are sending 3 more for a total of 4 parameters to the function draw fish. The first number that comes through when we call it is a number that gets applied to the word size, and anywhere in the function that says size will get whatever number is in the function call in that first slot. Then we're sending it 3 more parameters that in the definition knows that the second parameter that comes through in this function call is amount applied to the red of RGB. The third gets applied to the green of RGB, and the fourth gets applied to the blue of RGB because they are down there. And you could call these, why not just call them R, G, well, never mind. My point of doing this is just to show you that you don't have to call them red, green, and blue. I do think it would work if you called them red, green, and blue. But the key is whatever you call it here needs to be the same thing in the actual definition. And so there's that. Okay, and is this one going to be random, I think? Okay, so we are getting our first math block, which are the orange blocks. And the first one is that we get is random number, the random number block. The random number block, when it's called, will give you a random number between the 2 values you put in there, inclusive. Okay, so if you put in 0 to 1, it's either going to give you a 0, 1. It also only gives you whole numbers to simplify things. For real JavaScript, if you said random number 0 to 1, it would give you a decimal with however many decimal places you wanted between 0 and 1. And I don't think it's inclusive, although it'd be difficult to test. But for our sake, random number is only going to give us an integer, a whole number, between the range we give it, between the minimum and the maximum. So they do have to be in order that way. We want to give it a random color, and we actually can give it a random size. Let's start by working on a random size. We're only really working on the draw fish definition. So the first number that comes through when we call it will get applied to this word size. Let's go to the call. And when we call it, we'll have it pick a random number. And our random number needs to be a range of fish that we like, which originally we were at 20 and 40. Let's have our random sizes be between 10 and 60. And now every time we call that first one's going to be a random. Let's do the same thing for the other fish between 10 and 60. Okay, and that gives us random numbers. Every time we call, it gives a different number. Well, not necessarily. It chooses a random number of that range. That makes sense. And does this one have random color also? Oh, for all three. Does it have different sizes? Okay, so let's do random size for the other ones. Okay, so draw starfish gets size. When we call draw starfish, instead of sending it 60, let's send it a random number between 10 and 80. And the same thing for the other one. Starfish size between 10 and 80. We probably should, somewhere in the draw starfish needs pen width. I don't think pen width needs to be sized, maybe pen width divided by 2. Yeah, that's a little chunky. Let's do size divided by 2. You can put arithmetic in the calls. There you go, and they're getting a different random number each time. And the draw seagrass, which is receiving a parameter that is the radius, how big the arc is. Let's give it a random number between, well, our two were 50 and 100. So how about between 40 and 120? For each, between 40 and 120. And is it giving us different size? Why is that not big enough? How about between 20 and 120? The variance on that doesn't seem super big. Either way, there you go. It's working. And we also want random colors. Only the fish at this point is sending a parameter for color. So we'll put a random number in this. And in this one, it actually is going to be easier to switch to show text because you can't really get to the end when the lines get super long. So let's do the red draw fish for the first one. The red needs to be between 0 and 255 random. And the green needs to be between, and this will give us a purely random color. Nope, not there. There. Pay attention to where you're doing it. You could choose a random color in a certain range, like give it the maximum blue and then a random amount of red and green, which will keep it in the blue family. But we want a full random 0 to 255 for all three of these. And it's actually the same block since we're doing full random for all 4 parameters. Guys, this is important. You might miss it if you're not paying attention. The random number that you choose has to be a range where you're okay with any one of those numbers happening. Our first parameter in draw fish is the size. A valid parameter would be, or a number, any number between 10 and 60 will work for size. For random color, if we want the full randomness of color, we need a random number between 0 and 255 for each of the other parameters, which are the redness, the greenness, and the blueness. Now we will get a random color for each fish and a random size for each fish every time we run the program. And that's a lot for today. Give me a second here. Let's see. And you can see how it's starting to get crowded on the right. I recommend sliding the slider over so you get more space. You can also switch to show text and move over. But again, be careful when you do show text because if you lose a parentheses or something, you might not be able to get back to it, back to blocks. I can help you if you have that issue. Oh, what are we supposed to do for the last one? There is one more bubble on 17. Yeah. Okay. So for bubble 16 is just a brief multiple choice. Just make sure you get it. Consider the various uses of random number. Each answer describes the use and shows how code shows a code example. Which one of the following is not a valid use? Okay, calling the parameters of a function, that looks good. Defining. All right, you can't use random number in the definition. I mean, you technically can, but not in the parameter definition. The definition, you are deciding what is actually being received. You put the random number in the function call to send a random number every time you call the function. And the same thing in these turtle functions are the same as function calls. We just didn't have to make the definition. Okay, so the function receive or the function definition is where you put that. All right, bubble 17, what do they want from us here? I think we just need to add a few things. Use a random number to add a variety. I don't think we have loops yet. Oh, we could put random in the move. Okay, so for the starfish, we want the starfish at the bottom. So we want the X to be somewhere not exactly on the edge. So at least 50 in from each side. So that would be an X random number between 50 and 50 from the other side is what, 270? And we want it towards the bottom. So the Y random number for each starfish is going to be at least 350, but no more than 410. And so that'll give us a random location. Well, at least for the one, let's do it again for the other starfish and get rid of that move too. Okay, so the starfish are now getting random size and random location. Let's do another move to random for the seagrass. The key for random for the seagrass, and I'll let you figure it out for the fish, but the key for random for the seagrass is the Y for each of the seagrass has to be 0. So, oh no, this is the Y. The Y move to a random number for X and exactly 0 for Y, which is, what did we say? I don't know, 270. So like I said, the move to for seagrass is some random X, meaning random left to right, and 0, oh, excuse me, not 0, 450 puts us at the bottom. And we'll do that every time we call draw seagrass. And the seagrass are anywhere now. And then I'll let you figure that out for draw fish. What's a good random XY for that? I'll give you a hint. It's going to look something like that. But choose good random X's and Y's for that. Okay. We could talk about the checks for understanding next time, but this is where we're going to stop now. And you can watch the video on